Okay, hi, welcome to Math 12A. It's Monday. You wrote your tests last week. I'm marking it. I have them almost all marked. I'm hoping by the end of today to have your marks back to you. Fortunately, you won't be able to know what you did wrong and what you did right. If you want to know, we maybe can talk over Google Hangouts or something. Maybe we can do a video call just one-on-one if you really want to know what you did wrong. Most of you are doing okay. The only thing to remember is if there's a greater than or less than sign in a question, you should have a number line in your answer, or like X is greater than this or less than this. There should be a statement somewhere that says that. It's not just X is 4. But there should be a number line involved whenever you have a greater than or less than sign. So for today's lesson, all you're doing is listening to this video. That's it. That's all your work. We are moving into chapter 6 and 7, and if you remember way back when we were actually meeting face to face, I said that chapter 6 we kind of skip over. We spend a day or two picking out the important parts, but there really isn't anything to do in chapter 6. What I want to do is I want to pick out the important theorems that are in there, because you're going to be using them in the next chapter. There's no point in doing a test on this or anything, because you're just going to use it in the next chapter. So I'm going to do this as quickly as I can. I am going to write the theorems, or at least some explanations of the theorems, on the board. If you go through your textbook, chapter 6, anywhere that there's purple writing, the purple writing is important. So for those of you who are self-motivated, this will work great. You just need to look through chapter 6 and look at some of those theorems and make sure that you understand what they're saying. I'm going to explain each one. If self-motivation is not your thing, you need to kind of make it a thing right now. So the first thing, I am in section 6.1, and normally I would spend more time on this than I am in this video, but I want to make this video quick. Well, as quick as I can. It's not going to be quick, I'm sorry. But I'm just going to pull out the really pertinent parts. Okay, so on page 339, and what I think I'll do is I'll just put it here. Page 339, they have the triangle sum theorem. And this sounds really fancy, but all it is something you already know, and that's all angles in a triangle add to 180 degrees. That is the triangle sum theorem, so nothing big there. But then there's also the exterior angle theorem. And the exterior angle theorem says the exterior angle of a triangle is equal to the sum of the interior opposite angles. So I want to talk about that a little bit. So what they're saying is, so I'm not going to write that all out. Again, it's on page 339 for you. But I am going to do a little example of what they mean. If you have a triangle and one of the lines extends out, okay, if you want to know what this angle is, okay, if you want to know what that angle is, it is equal to the interior opposite angles. So if this was A and this was B, this angle would equal A plus B. You could also say that this angle and this angle are supplementary, and what that means is they have to add up to be 180. All right, that's it out of section 6.1. I told you this was going to go quick. I wasn't kidding. We're skipping 6.2. Normally I'd talk a little bit about it, but I'm not even going to bother. They talk about deductive reasoning, inductive reasoning, examples and counterexamples. Doesn't really matter. I just really give an English lesson for this. But another theorem that you need to know, okay? So this is the exterior angle theorem. It says that the exterior, the outside angle on a triangle, is equal to the sum of, so adding, the interior opposite angles. So if I take A plus B, that tells me what that is. All right, that's the exterior angle theorem. And again, they have it in fancy words for you on page 339. So we're skipping all the way over to page 348, where they give you another theorem, which is the opposite angle theorem. And the opposite angle theorem says when two lines intersect, when two lines cross, the opposite angles are equal. So I have a line here and a line here. They cross. So this angle and this angle, they are opposite to one another. Those are equal. Also, this angle and this angle are opposite to one another, so those two would also be equal. Again, if you use logical reasoning with this, by the way, all four of them would have to add up to 360 because it makes a circle. So they do something kind of cool in example number 1 on page 348. So I'm just going to do it with you just as a game. This is just fun. All right, there's no math. Well, I mean, there's math involved, but there's no earth-shattering thing here. Example 1 compares what's called inductive reasoning and deductive reasoning. Inductive reasoning just says you kind of do an example. So you're all going to do an example to see if it works. So I want you all at home to choose a number. I don't care what number it is, just choose a number. Make it something simple, make it easy on yourself, okay? So choose a number, double it. So multiply it by 2. So choose a number, double it. Now I want you to add 5. All right? Now, whatever your original number was, add it to that number that you have. All right, now I want you to add 7. Now I want you to take whatever number you have and divide it by 3. And now I want you to subtract the original number that you chose. And you should all get 4. So if you're wondering how did I do that, deductive reasoning would actually get you to set up a formula for that. So when it says choose a number, here I chose a number, I chose X, and it says double it, so I'm going to multiply it by 2. And then add 5. Okay? And then I said add your original number, so add X. So if I simplify that, now I have 3x plus 5. Then I said add 7. So if I add 7, now I have 3x plus 12. Then I said divide by 3. So if I divide this by 3, 3 divided by 3 is 1x, and 12 divided by 3 is 4. And then I said subtract your original number. Well, my original number was x, so if I subtract x, I get 4. So it doesn't actually matter what number I choose, I'm always going to get 4. All right, so that's just what deductive reasoning is. Deductive reasoning is not necessarily just trying every possible scenario, but it's coming up with a generic statement that would prove what you were talking about. So we're done. Section 6.3, and we're moving into section 6.4. Section 6.4, I do normally do some homework with, but we're not going to this time. Again, I'm really kind of canceling out some stuff. So they talk about a Venn diagram. We do a Venn diagram again later. You've done Venn diagrams before. We don't need to rehash it, okay? So they talk about doing a Venn diagram. If we have time at the end of the year, maybe we'll go back and look at that, but it's not really all that important. And then we talked about graphing on a number line. Well, we've just been doing a whole lot of graphing on a number line, so we're just going to skip that for now. And then we're going to go, and again, we're going to head into section 6.5, where normally I would spend a little bit of time talking about contrapositives and biconditional statements, but we're actually going to skip over some of that. So 6.5, yeah, I'm not pulling anything out of there. Isn't that great? All right, then we get to section 6.6, and here's where most of the proofs are. All right, so section 6.6. So I am on page 367, page 367, and they give some theorems about parallel lines. So parallel lines, just two lines with the same slope. So there are two parallel lines. They're going to give us a whole bunch of theorems about parallel lines. They're going to put it in geometry language. I'm going to try and give you some easier ways to see it, maybe than how they're explaining it. I hope. That's my goal. All right. So just a second, I gotta check how much battery I have left because I was running low. Just a sec. Okay, it's not telling me low battery, so I guess I can keep talking. So one of the theorems on page 367 says, if a transversal, so we need to talk about what a transversal is. A transversal is just a line that goes through the two parallel lines. So there you go, there's a transversal, all right? So fancy language to mean something very, very simple. Please don't let the language throw you. A transversal intersects two lines, and when it does, the alternate angles are equal. So all of these next few theorems are going to be, they are parallel, no, wait, sorry. They are going to be transversal parallel line theorems, all right? So these next few, that's what they're going to talk about. They're going to talk about it for several different pages here. So the very first one on page 367 says, if a transversal, and here's my transversal, if it intersects two parallel lines, here are the parallel lines, the alternate angles are equal, all right? So as long as these two lines are parallel, what they call the alternate angles, this one and this one, are equal. Just a sec, I need to grab a different color. So again, in their language, if a transversal intersects two parallel lines, then the alternate angles are equal. Now, geometry is not my thing. It's not my best subject. So I stole some stuff from another teacher that I was tutoring someone, and this teacher had given them a sheet of these shortcuts, these ways of remembering. The alternate angle, the alternate angle rule, the one that says when a transversal passes through two parallel lines, the alternate angles are equal, he called that the Z rule. And let me explain why. If I make a letter Z here, the corners of the Z are equal. Now, it doesn't matter whether my Z is forwards or if I make a backwards Z, then this angle and this angle would be equal. Okay, alternate angles are equal. Also was called the Z rule. Now in a geometric proof, you couldn't write the Z rule because that's not a geometric proof. That is some teacher's way of explaining the transversal parallel line theorem, which is what you would have to write. All right, so that's the first one. So the next one, when we have two parallel lines and we have a transversal going through it, all right, the next one says the corresponding angles are equal. So let me do that in a different color. I don't know how many colors I have here. So let me do that in a different color. So according to that, this angle here and this angle here would be equal, all right? You could also look at it as this angle and this angle are equal. The person I stole this off of called it the F rule, because if I make a letter F, okay, the corners in the letter F are equal. It is called the corresponding angle. It's called corresponding angles are equal. So it's still the transverse parallel line theorem. It's just one piece of it. So one piece of the parallel line theorem says alternate angles are equal. Another piece of the parallel line theorem says that corresponding angles are equal. Something that the teacher I stole this off of calls the F rule. All right? So the next one, still transversal parallel line theorem. This one says that co-interior angles on the same side of a transversal are supplementary. So blue. So what that means, co-interior angles, fancy words, co-interior angles are supplemental. The word supplementary, you're going to hear that a lot in geometry. You should have taken this already somewhere before, but the word supplementary means, and I'm just double checking, means that they add up to just a sec, means that they add up to I think it's 180. I'm just double checking. It's late on Sunday night and I'm tired. Just a sec. Pause for this moment. I could sing a song. You don't want me to do that though. All right. Supplementary. So, yep, 180 degrees. I'm right. I just wanted to double check. I didn't want to tell you wrong. All right. So this angle and this angle would add up to be 180 degrees. He called this the C rule. Again, I can make a really wonky letter C, but he was trying to have a theme here. So letter C, the co-interior angles add up to be 180 degrees. They are supplementary. Again, the C does not have to go this way. It could be a backwards C. It just means if you can make some semblance of a letter C, it's going to add up to be 180 degrees. So the transversal parallel line theorem says alternate angles are equal. That's the Z rule. It says that corresponding angles, so like this one and this one, are equal. That's the F rule. And then co-interior angles are supplementary. They add up to 180. That's the C rule. So those are the transversal parallel line theorems. They are listed for you in several different ways, actually, on page 367, 368, and 369. They say it like 3 different times, 3 slightly different ways, but they all mean the same thing. So there you go. All right. Again, normally I would go through some of these proofs with you, but I'm not going to bother because it takes a really long time, and I just don't think it's going to translate well over YouTube, okay? If we needed to, if I thought it was really important, we would do it. Maybe we would do a live chat on it, but I know it's not going to be that important for later on. One theorem that is important is on page 370. Page 370, and that is the isosceles, I probably spelled that wrong, isosceles triangle theorem. And again, it's on page 370. I'm trying to make a list of the important ones so that if you are a note taker, if you are someone who likes a list of notes to study off of, you can go and you can copy out those theorems on those pages. I don't have a big enough board, and it would make a really long video if I stood here and wrote them all out for you. The isosceles triangle theorem. First of all, in order to explain the isosceles triangle theorem, you need to know what an isosceles triangle is. An isosceles triangle is one where 2 sides of the triangle are equal. So let's say this side and this side. So the isosceles triangle theorem says that in an isosceles triangle, the angles, let me see how they word it, just a second. They say the angles opposite the equal sides are also equal. So in other words, this angle right here, that is opposite that side, and this angle right here, those also have to be equal. We're going to be using this one quite a bit, so you really need to know this one. I would put a little star beside that one. That one is important. That the isosceles triangle says that if you have an isosceles triangle, meaning 2 sides are the same, then the opposite angles are also the same. And again, you can do what's called the converse of that. If you have a triangle and you know these 2 angles are the same, then you know these 2 sides are the same. It works both ways. That's what the converse means. It works this way and it also works backwards. All right. I think I might be done talking. Just a sec. Yep. I'm actually done talking. That is really the important parts out of chapter 6. That is the important part. So let me let you in a little bit on what chapter 7 looks like. And again, some people really like chapter 7. Some people really hate chapter 7. And who knows? Sometimes the people for whom math is very difficult, they actually like chapter 7. Chapter 7 works out really well for you. Chapter 7, the very first section, please don't judge the whole chapter on the first section. The first section is doing geometric proofs. So a bunch of statements, a bunch of reasons in order to prove something. We're going to go through that step by step. The good news is you're never going to have to do a geometric proof on your own. We're going to do fill in the blank for that, but you're never going to have to come up with one right out of the blue because they're not fun. But from there on, there's actual math involved. But you have to know these theorems in order to figure it out, because you're going to be figuring out missing sides and missing angles of triangles and circles and different things like that. And you're going to need to know these, because when you figure out that this angle is let's say 50, and if you know that opposite angles are equal, then you know the angle opposite that is also 50. So you're going to have to be able to know those theorems in order to use them to find missing numbers. Like I said, not really high-level math, but high-level logical thinking in order to do it. So that's where we're headed over the next little bit. You do have an assignment that is due March 30th. That is due March 30th. And I don't know that we're going to do a unit test at all. Normally by the end of the quarter, we would do a unit test. But what I may do, just because of the unique scenario that we're in, what I may do is, rather than do that, just play with the weights of things. So the weights that I gave you in your syllabus at the beginning of the year, where it says like your assignment's worth 10% and tests are worth this percent, I may just play with those percentages a little bit. Class mark may go, like right now class mark is 20%, I may put that higher. So if you are sending me all the stuff via Google Classroom that you're supposed to, you may be able to get more than 20% for your grade. Again, because that's the only way I know that you're out there somewhere doing what you need to do. So it's really, really important that you do that. So I may weight that a little bit higher than I normally would, because if I'm at school, I can check in with you. How you doing? How's it going? It's a little bit harder to do that. I am trying to keep in touch with you via Google Hangouts, private messaging some of you, but it's certainly more difficult than if you're just in my class and I can go, hey, how you doing? The more communicative you are with me, the better. That way I know what's going on. Again, I am trying very hard to keep in contact with you from 8:30 to 3. After 3, you can message me, like just let me know I need you to do these questions or whatever, but I don't want to get into a big conversation after 3 o'clock. I do need some personal time too, and so do you. You need to put it away. So we'll see you again. No homework right now other than be working on your assignment for March 30th. We're going to start into Chapter 7 on Tuesday. All right? See you later.